Fusion Mobile, quality e-learning experience on the go.
Good day, you're welcome to Fusion Mobile e-learning class. My name is Bolaji, as usual. We are about to do the subject called mathematics, and the topic is called matrix and determinant. Matrix and determinant. Matrix and determinant. Matrix and determinant. What is a matrix? Definition of a matrix, so as to know how we can compute or solve these kind of equations that involve an element being arranged in a rectangular form. Matrix is defined as a set of numbers arranged in a rectangular pattern. Matrix defined as a set of numbers arranged in a rectangular pattern. Therefore, how do we know their orders of arrangement? How do we know how they are being aligned? How do we know their pattern? That gives back what is called order of matrix. Order of matrix. Order of matrix. Order of matrix. Order of matrix means arrangement of the element of matrix in terms of rows and columns. In terms of rows and columns. Example, let's consider this example. A is equal to A, 1, 2, 3, 4. And B is equal to X, Y, Z, U. Now, what is the order of this matrix? We have what is called rows and we have what is called column. So the order of this matrix, it means the elements of A, the elements that compose matrix A, they are arranged in columns, they are arranged in rows. That is 1, 3 columns, 1, 2 rows. So the elements in this matrix A are arranged both in columns and in rows. Also, this matrix B, it has this element XZ, YU. XZ is arranged in column, while XY is arranged in rows. So these are the patterns by which an element of a matrix B can be arranged. So this is pattern, and this shows a rectangular pattern in a rectangular figure that elements are arranged in rectangular pattern. I would like you to solve this and explain the definitions of matrix. Thank you. I like your definitions and your response to the question. Let's proceed to types of matrix. Types of matrix. Type of matrix. Type of matrix. Type of matrix. 1, we have equal matrix. We have equal matrix. We have equal matrix. Two, we have zero matrix. Zero matrix. 3, we have identity matrix. identity matrix. 4, we have inverse or negative matrix. Inverse or negative matrix. We have row matrix. We have row matrix. We have row matrix. We have column matrix. We have column matrix. Other type of matrix are 2 times 2 square matrix, 3 times 3 square matrix. Others are 2 times 2 square matrix and 3 times 3 square matrix. We have 2 times 2 square matrix and 3 times 3 square matrix. I want to explain equal matrix. Equal matrix. Equal matrix. What is equal matrix? Equal matrix are type of matrix in which the elements, that is the corresponding elements, are equal. That is the corresponding element of the two matrices being considered are equal. For example, what is equal matrix? Where we have A is equal to 1, 2, 3, 4, and the matrix B is equal to X, Y, U, B. Now, how is it equal? The elements, the corresponding elements are equal to this. We have 1 is to 1, 2 is to Y, 3 is to U, 4 is to B. They have a corresponding element. They are a corresponding element. Both in terms of rows and in column, we have column 1, 2, 1, 3, we have X, U. We have 2, 4, we have Y, P. Or we can easily put it like this. If you see mine, because of the alphabetical order, we have A, B, C, D. If for us to understand it, why? But you see the same thing by considering their corresponding elements in this order of matrix. So the equal matrix have the same column number and in terms of row with considering the elements in B. So equal matrix means that if the element in the two corresponding matrices are equal, and that is called equal matrix. Let's proceed to the other type of matrix that I explained, which is called zero matrix. A zero matrix is a kind of matrix in which the element is zero. That is, every element that is embedded inside this matrix is equal to 0. Let me give you the example of it so that you understand it. That is equal zero matrix. Zero matrix. This is A equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. Therefore, zero matrix means that every element inside this matrix A is equal to 0, is 0. So this is an example of a zero matrix. It will now move forward by going to identity matrix. Identity matrix, so that as I explain it according to our ranges, identity matrix. Identity matrix is a type of matrix in which the operation of matrix in terms of the addition does not change the value of the element. The arrangement of what the element inside the matrix, no matter the operations in terms of their addition, doesn't change the value. Let me give you this example. Consider matrix A also, where you have 1, 2, 3, 4, and B is equal to 0, 0, 0, 0. Therefore, if A plus B is the equations we have to solve, it means that 1 plus 0, then 2 plus 0, here 3 plus 0, here 4 plus 0, which is equal to 1 plus 0, 1, 2 plus 0, 2, 3 plus 0, 3, 4 plus 0, 4. So it doesn't change the value inside the element. No matter the operations in terms of addition, doesn't change the value. So it's an example of an identity matrix. Let's move on to what is called inverse matrix. Inverse matrix. Inverse matrix is a negative matrix. Inverse matrix is a negative matrix. Inverse matrix. Inverse matrix or negative matrix is a kind of matrix in such a way that matrix A plus inverse of A is equal to 0. Is a negative matrix. That is, if we have matrix of A and the inverse of matrix of A, the element inside of it, is equal to 0. That's the explanations, a brief explanation of this type of matrix. Row matrix has been explained if an element is being arranged in rows, columns, if it is arranged in columns. Thank you. I would like you to just explain these few type of matrix. Wow, you have understood this type of matrix. I'm confident that any question you see, you'll be able to explain well. But we have to move further to a topic under this matrix. And this topic is a subtopic under this matrix, and the subtopic is called addition and subtraction of matrix. 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 The word addition means sum. The word addition means sum. Let's consider this question. If A is equal to 4 minus 5, 9, and we have 1 is 0 minus 3, and our B is equal to minus 3, 1, 8, 0, 2, minus 6. Find A plus B. The meaning of this A plus B means addition. Find A plus B. Solution to this question is that A plus B is equal to 4 plus minus 3 and minus 5 plus 1 and 9 plus 8. Then the next one is 1 plus 0, this and this, 4 and this, minus 5 and this, 9 and this. Each row affects each row. Each row of the element affects each row. 1 and this, 0 and this, minus 3 and this. That is why I consider 4 plus minus 3, minus 5 plus 1, 9 plus 8. Because the question said find A using A first and add B. 2, 1 plus 0, then is 0 plus 2. Here, minus 3 plus minus 6. That's the additions. We continue by solving our question. Remember that signs affect our answer. Remember sign that we did in junior secondary school, that is plus times minus in this aspect, is going to turn to minus. Therefore, 4 minus 1 will give us 1. Minus 5 plus 1 will give us minus 4. 9 plus 8 will give us 17. 1 plus 0 will give us 1. 0 plus 2 will give us 2. Minus 3 plus minus 6 will give us minus 9. How do we have minus 9? Plus times minus to give us minus. So minus 3 minus 6 will give us minus 9. Therefore, A plus B is equal to 1 minus 4, 17, then 1, 2, and minus 9. That's the answer. I would like you to do this few evaluation so as to know how we can solve additions of matrix. Welcome. I am confident that you know how to solve matrix in terms of additions operations. Let's consider another example that involves subtractions. Subtractions of matrix. Subtraction of matrix. Let us consider an element in matrix A, that is, if A is equal to 3, 4, 2, and 1, 2, 3, and minus 2, 1, 0, and our B is equal to 3, 1, 4, minus 1, 3, 2, and 2, 1, minus 1. Subtraction of matrix. Then find A minus B. Find A minus B. The answer to this question, A minus B, is equal to 3 minus 3, 4 minus 1, 2 minus 4, then 1 minus 1, 2 minus 3, 3 minus 2, then minus 2, minus 2. 1 minus 1 is 0 minus minus 1, which is equal to 3 minus 3, which will give us 0. 4 minus 1 will give us 3. 2 minus 4 is minus 2. 1 minus minus 1. 1 minus times minus will give us plus. Therefore, 1 plus 1 will give us 2. 2 minus 3 will give us minus 1. 3 minus 2 will give us 1. Minus 2 minus 4 is equal to minus 4. 1 minus 1 is 0. Is 0 minus minus 1, which will give us plus 1. Therefore, matrix A minus B is equal to 0, 3, minus 1, 2, minus 1, 1, minus 4 is 0 and 1. I'm confident that you understood this subtraction of matrix. I would like you to do this field evaluation. Wow, welcome back. I'm happy that you were able to solve questions under the subtractions of matrix. Let us move forward to multiplications of matrix. Multiplication of matrix. Multiplication of matrix. For example, if A is equal to this matrix, if A is equal to 2, 7, minus 4, 3, find 3A. That is, if element A is 2, 7, minus 4, 3, find 3A. Solution. The solution, that is 3A, is equal to 3 times 2, then 3 times 7, then 3 times minus 4, then 3 times 3. The meaning of multiplications of these 3A means 3 affect each element in A, which is equal to 3 times 2, 6, 3 times 7, 21, 3 times minus 4, minus 12, 3 times 3 is equal to 9. Therefore, the element of 3A is equal to 6, 21, minus 12, and 9. Thank you. I believe you were able to understood this example on the multiplication of matrices. I'd like you to solve these few evaluations so as to know how far we have gone. Thank you for the answers. I'm very happy because you were able to solve the questions correctly. And I believe by the time we begin to see a few questions ahead, we'll be able to solve them easily. Lastly, let us consider transpose of matrix. 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 What is the meaning of a transpose of matrix? For example, let's consider this. If A is equal to 1, 1, 2, 3, 4. Find the A transpose. The meaning of A superscript T means find the transpose of T. Solution. Solution to this is that AT is equal to, this is row, and this is column, and this is row. It means we transfer the column, the elements in this column, to the row. Now we have this first element in this column, which is 1, 2, 3, 4. We transfer these to be in column. Therefore, the answer is 1, 2, 3, 4. That's the transpose, rearrangement. Changing the order of pattern from the column to the rows. I believe you understood this transpose of matrix and the order transpose as we have explained earlier on. Let me give you this evaluation to conclude this matrix, type of matrix, and those of the question we have solved.